Alright, let's take a look at how to perform synthetic division. And the first thing is, what is the purpose? The purpose of synthetic division is to factor polynomials. And let's just quickly discuss what factoring is and why we do it. Let's start with a simple quadratic polynomial, like x squared plus 4x plus 3, and we set the polynomial equal to 0. So this is a pretty simple quadratic. We can factor it by doing x plus 3, x plus 1, set that equal to 0. And by doing this, we can determine the roots of the polynomial. The roots are the values of x that make the polynomial equal to 0. On a graph, those roots will be the points where the graph crosses the x-axis. So what values of x make this true? Right? So any value of x that makes either factor equal to 0 will make the entire expression equal to 0. So here, x equals negative 3. So if I substitute negative 3 in here, then that makes this factor equal to 0. Or over here, x equals negative 1. Right? And by substituting this value in here, that makes that factor equal to 0. So this is how I determine the two roots of this particular function. Now we don't always have nice, friendly quadratic equations, so synthetic division is a good option when you have a polynomial that has a higher order, the order being the highest power of x, or whatever variable is used for the polynomial. But in a quadratic, the highest power of x is x squared, so we would call it a second order polynomial. If the highest power of x is x to the third, then that's a third order, and so on and so forth. So to demonstrate this process of synthetic division, I'm going to use one of your example problems. Our function is x to the third minus 4x squared plus x plus 6. Okay. And it tells us that x minus 3 is a factor. Okay. So really what it's asking us to do is it's saying take this function x cubed minus 4x squared plus x plus 6 and divide by x minus 3. Now one way we could approach this is by doing long division, but synthetic division is a shortcut. It makes life a little simpler as long as you, of course, understand the process here. So I've rewritten the polynomial emphasizing the coefficients here, because when we do synthetic division we just take these coefficients. So we set up this what looks like an upside down division symbol, and we're going to take each of these coefficients and write them in here in order. Okay, so we have 1. We have to be really careful here because this isn't just 4, this is actually negative 4 because we're subtracting. So minus 4, 1, 6. And remember, we're told that x minus 3 is a factor. That means that x equals 3 is a root. So this 3 is what goes here. And we start by just bringing this 1 down. And we then multiply 3 times 1, and that product goes here. And the next part is to add down. So we have negative 4 plus 3 gives us negative 1. And then we repeat this process. And the next step, we repeat. So we take this 3, we multiply by the negative 1, gives us negative 3. And then we add down, gives us negative 2. Once again, we have this new value of negative 2, and we take our 3 and we multiply to get negative 6, and then we add down to get 0. Now since the remainder is 0, this last term here tells us whether or not we have a remainder. If the remainder is 0, then that means that our factor of x minus 3 is indeed a factor. Now using this information, we can write the other factor, or rather the quotient that results from dividing our original polynomial of x cubed minus 4x squared plus x plus 6, dividing that by x minus 3. What is the other factor? Well, each of these values that we have here, these are coefficients in the resulting polynomial. Now, since we're dividing a polynomial that has an order of 3, dividing by x, then that means that the factor in our quotient here would have an order that is divided by 1. I'm sorry, reduced by 1. Okay, so that means my answer is going to be on the order of x squared. So this 1 here goes with x squared. Then I have this negative 1 here, becomes negative 1, and then x. So each term, the power of x is going to decrease by 1, right? So x squared, then x to the first power. And then here, this is my last term, x to the 0 power, or really, x to the 0 power is 1, so we just simply have negative 2. All right? So what this means is that x cubed minus 4x squared plus x plus 6, if we divide by x minus 3, the result is x squared minus x minus 2. Or another way we can write this is x squared minus x minus 2 times x minus 3, and that is our answer. But we're not quite done yet. If you notice, this is a quadratic, and if you look at the coefficient of this term and our constant term, you should see that this can be factored as well. So what are two numbers that multiply to make negative 2 and add together to make negative 1? So we have x minus 2 times x plus 1. So my final answer should be x minus 2 times x plus 1 times x minus 3. So we have completely factored the polynomial. And then it would also be a good idea to just multiply these three factors out to make sure that you end up with your original polynomial, just to double check. I'm not going to do it here, but just recommend that you do when you're doing your work. Okay, one final example. Just take another one from your sheet, and this is on number 4. And it is 2x to the 4th minus x cubed plus 4. And it asks you to divide by x plus 1. So one thing you have to really watch out for here is if you look at all the terms and the successive powers of x, so the leading term, right, the leading term is the term with the highest power of x. We have 2x to the 4th, followed by minus x cubed, and you should notice that there's no term that contains x squared or x, and that's okay, but we just have to account for it when we do our synthetic division. So before I actually do the division, I'm going to rewrite the polynomial with all the successive terms of x. So I'll rewrite this as 2x to the 4th minus x cubed plus, since there's no x squared term, I'm just going to write 0x squared plus 0x plus 4. Run out of space here, so forgive me. And so when I set this up, my coefficients are 2 negative 1, 0, 0, and 4. And since I'm dividing by x plus 1, right, we have to ask what value of x makes x plus 1 equal to 0. So x must be negative 1. That's our initial setup. Okay, so here's our setup. We have 2, negative 1, 0, 0, 4. Dividing by x plus 1, so negative 1 is here. Right, so we start by dropping down the 2. So negative 1 times 2 makes negative 2. We add down negative 1 plus negative 2 gives us negative 3. So we repeat the process. Negative 1 times negative 3 gives me positive 3. We add down, 0 plus 3 gives me 3. Once again, negative 1 times 3 gives me negative 3. Adding down, 0 minus 3 is negative 3. And one last time, negative 1 times negative 3 gives me positive 3, which gives me a remainder of 7. So we have a remainder, and that's okay. So what that means is we're going to rewrite our answer as such. Remember that our polynomial was 2x to the 4th minus x cubed plus 4. That means our quotient, the leading term of our quotient, will be one. The order is 1 less than the original. So since we had 2x to the 4th, my answer is going to be, the order is going to be x to the 3rd. So taking this first coefficient here, 2x cubed minus 3x squared plus 3x minus 3, and then the remainder is going to be 7 over, what are we dividing by? X plus 1. And I'm sorry, it's kind of messy. My screen isn't that wide, so I'm running out of space here. And that's it. That's all you got to do. All right. So I hope this helps. Feel free to email me or call me anytime. I do have FaceTime on my iPad, so we can do FaceTime, or we can do video chat through Facebook Messenger. But I hope this helps. Please just get back to me, let me know, and I'll do all I can to help you out. All right, take care.